Welcome back. Now that we know what the various variable types are and how to define them, let's work on a few examples of how variables are used when coding. Let's begin by opening up our LabMaster source code file and scroll down to the last button events that we worked on. If you remember, the nesting weights and stacking weights button events are virtually identical. I'll leave the nesting weights button event intact so you can reference it in the future. However, we'll add some variable stuff to the stacking weights button event. Our mission: create a variable to track the power status of our amplifiers that we turned on in the previous lesson. Then we'll use the variable in a feedback statement to properly update the touch panel so the end user has a visual confirmation of the status of the amps in the rack. Before we begin to write our code, we need to do some touch panel work. Let's open up our touch panel and launch the Relays pop-up page. Remember when we added the rack power button to turn on our amps? In order to make things crystal clear, let's change the text on this button for both the on and off states. I'll select the button and choose States in the button properties. First, I'll change the off state. In the text field, I'm going to have the button say, Rack power is off. Notice how the text looks on the button. We need to set the word wrap field to Yes. That looks much better. Now for the on state. I'll change this text to say, Rack power is on. Once again, I'll set word wrap to Yes. To see how the button looks, we can toggle its state on and off using the Display Next and Previous State toggle buttons, or if you prefer, F11 and Shift F11. We have just one more thing to do. As of right now, we have no way of turning off the amplifiers. In later tutorials, we'll learn how to use this same button to do both turning on and off the racks, but for now, we are just going to create a separate button. Let's open up the main page. In the top left corner, I'm going to add a System Off button. Using the Button Draw tool, I'm going to just draw a simple button. I'll set my cursor back to the Selection tool and move my button into position. Instead of text, I'm going to add an image to this button. I've already imported an image into my Resource Manager. As a reminder, up in the Panels menu, select Resource Manager. Here you can import any image that you may have and then use it in your touch panel. I'll close this. With the button selected, I'll go over to States, All States, and select Bitmaps. I wish to add a bitmap. I'll scroll down through all of my bitmaps until I find the one I wish to use. Power symbol off is what it's called. Highlight it and select OK. Notice the bitmap justification is set for center middle. If we click OK, notice how awful the image looks on the button. That's because the resolution of this particular image is greater than the size of the button. There are two things you can do. One, you can change the resolution of the image in a program such as Paint or Photoshop and then re-import it. Or two, you can go back into the Bitmaps dialog box and change its bitmap justification to Scale to Fit and hit OK. So it still doesn't look quite right. Because we are scaling the image, it is stretching it to fill the entire button. To fix this, simply change the dimensions of the button to be perfectly square. I'll make mine 60 pixels wide by 60 pixels high. Perfect. Now I'll just change the fill color to transparent, and it looks great. The last thing we need to do is assign this button a channel port and code. Under the Programming tab, we'll keep the channel port set to 1, and we'll assign the channel code 99. We're all set. Save and close our touch panel, and let's get back into our code. To begin with, we need to create a global variable that we're going to use in order to track the power state for our rack of amplifiers. Let's scroll up to the Define Variable section of our code. First, we declare the variable's persistence. A variable such as this one is not critical that it maintains its value if the processor gets rebooted. Therefore, we'll just set this variable to volatile. Next, we need to assign the type of data this variable is going to hold. Because we are simply tracking the on or off state of this rack, a simple integer variable will work great. Why an integer? In programming, everything boils down to ones and zeros. It's no different for this variable. An integer variable with a value of 1 is also said to be on, and I'm sure you can guess, a value of 0 is synonymous with off. Now we just need to give our variable a name. Remember, we can name this variable whatever we wish, but we should keep it relevant to what we are doing. It begins with the Hungarian notation for an integer, which is lowercase n. I'll call it namp power status. That's it. Our global variable is defined and can be used anywhere in our code. Let's scroll back down to our button event. It's incredibly easy to use our variable. After all our amps are turned on, that's when we need to set our variable on. All I need to type is namp power status gets 1. But what about turning it off? Well, we haven't created a button event for that yet. Let's quickly do that. Button event, dvtp. Do you remember the channel that we used for this button? I'll scroll up and create a new constant for this channel. I'll call it system off button, and it gets 99. Now, what do we want to do when this button is pressed? Well, let's first turn off all the amplifiers. There's no need to stagger these using weights like we did when powering them on, so just add off statements for each digital I/O. Then we simply set the amp power status variable to off using the statement namp power status gets 0. As far as the code goes, that's it. All we need to do now is the feedback for our button. If you remember, the rack power button on the touch panel is the one we changed the on and off state text to read rack power on or rack power off. Scroll down to the define program section of our code. Let's add another line of feedback. The first part is more of the same. The dev-chan combination for the button on the touch panel is dvtp, rack power button. This is where the difference comes into play. Instead of associating this button with a particular relay or a digital I/O, we can associate it with our variable. All you need to do is type gets namp power status followed by a double equal sign and then a number 1. This entire evaluation statement needs to be enclosed in parentheses. The double equal sign is used to evaluate two values. In this case, we are comparing whether or not namp power status holds the same value as the number 1. If they match, then the evaluation is true and the button goes on. If namp power status holds a value of 0, then they won't match and the button turns off. We'll learn much more about the differences between the single equal sign and the double equal sign in a later tutorial. In part 2 of this tutorial, we'll create another variable and learn how to use the debugger in NetLink Studio.